Hi Year 11. Today we are going to stick with our quantitative chemistry topic and we are going to consider the mole. And we are turning in our booklets to page 134. Now a mole in chemistry has nothing to do with the wee furry creature. A mole is actually just a quantity that we use in chemistry. So it's a quantity that we use to compare the number of particles of any substance with the mass of that substance. Now, why can't we just count the number of particles? If we consider two elements, so let's just pick the element hydrogen and let's just pick the element carbon. Now, hydrogen's relative atomic mass, its top number in the periodic table, is 1. So let's just take 1 gram of this hydrogen. Now, if I go and think about carbon's relative atomic mass, its top number in the periodic table is 12. So let's just take 12 grams of carbon. Now, I'm going to tell you that in 1 gram of hydrogen, there are the same number of hydrogen atoms or particles as there are in 12 grams of this carbon. So we could say that this number is X number of particles or X number of atoms. Now we know from our relative atomic mass studies that an atom of carbon is 12 times heavier than an atom of hydrogen. So if I want to link this mass of hydrogen and carbon to a mole, what I have got when I weigh out 1 gram of hydrogen and 12 grams of carbon is a mole of hydrogen and a mole of carbon. And there's our first definition that we are going to write into the box on page 134. So 1 mole is the relative atomic mass, the AR if it's an element, or like we'll see shortly, if it's a compound, it's the relative molecular mass expressed in grams. So if I want to weigh out a mole of any element, I would go to the periodic table, I would find that element's top number, I would weigh out that top number in grams, and I would have a mole of the substance. So like we've been chatting about hydrogen and carbon, this 1 gram of hydrogen contains the same number of particles as 12 grams of carbon. I've got 1 mole of hydrogen and 1 mole of carbon. Now, why don't we just talk about the number of particles rather than having to introduce this mole? And the simple reason is because the number of particles is absolutely huge. 1 mole of any substance contains 6.02 times 10 to the power of 23 particles. And this is called the Avogadro number. And you'll be glad to hear that we don't need to remember that number. So we know that particles are absolutely tiny and atoms are absolutely tiny. So therefore, if we are going to consider the number of particles because they're so tiny, this number, like I've said, is absolutely huge. So the mole makes it a little bit easier when we're trying to consider the number of particles or the number of atoms. Now, how do I get 1 mole? In our notes, you can see, we've already said that 1 mole of carbon is just its top number in grams, that's 12 grams. So if I want to go and I want to find how to get a mole of different elements, well, I'm just putting their top number into grams. So 1 mole of calcium is calcium's top number. If I were to weigh out 40 grams of calcium, I would have 1 mole, and this 1 mole would contain 6.02 times 10 to the power of 23 calcium atoms or calcium particles. Now a mole of sodium then contains 23 grams. A mole of chlorine then, be careful because chlorine is diatomic. If I want to get 1 mole of chlorine, I would need to weigh out 71 grams of chlorine. Now I mentioned it just briefly. We can also use moles when it comes to compounds too. using the MR of the compound. And if we were to quickly revise MR, if I were to consider this calcium carbonate, if I want to get calcium carbonate's MR, well, there's one calcium there, and calcium's top number is 40. There's one carbon, top number 12. There are 3 oxygens, so 3 times 16 is 48. When I add that all together, the MR, or the relative formula mass, or the relative molecular mass, they're all the same thing, is 100. So if I want to weigh out a mole of calcium carbonate, I would need 100 grams. Now, if we were to consider carbon dioxide, 1 mole of carbon dioxide, well, 1 carbon, so that's 12, 2 oxygens, so that's 32. Add it together then, I would find that the relative formula mass, or the relative molecular mass, or the MR of carbon dioxide, like I've said, they're all the same thing, is 44. So if I want a mole of carbon dioxide, I would need 44 grams. So 1 mole of this calcium carbonate, this 100 grams, and 1 mole of carbon dioxide, this 44 grams, actually contain the same number of particles, or the same number of molecules. And it's that Avogadro number, the 6.02 times 10 to the power of 23. It's a huge number of molecules or particles. Now, what we need to be able to do is we need to be able to work out the number of moles in a certain mass of any element or compound. Now, we're at the bottom of page 134, and you have got this little formula, and it would be worth highlighting. So the number of moles is always the mass in grams divided by the AR, the relative atomic mass, or the MR, the relative molecular mass, or the relative formula mass of a compound. Now, we could put this into a triangle, and the triangle comes in handy if we're asked to rearrange this formula. So the mass in grams will therefore be equal to the number of moles times the AR if it's an element, or the MR if it's a compound. Rearranging again then, if we're asked for the AR or the MR, that will be the mass divided by the number of moles. And it would be worth writing these two at the top of page 135, because in some of the questions we will be asked to rearrange this moles expression. So it's really important that we learn and we remember this moles expression. Now, if we look at examples, we're asked at the bottom of page 134, how many moles are there in 54 grams of water? Now, the number of moles, remember, is the mass divided by the MR. So the number of moles is the mass divided by the MR. I need to work out the MR of this water. I've got 2 hydrogen and 1 oxygen, so I'm looking at their top numbers. When I add them together, this adds to 18. So if I go then and I say I've got 54 grams, I know that 1 mole is 18 grams, and I divide them, I can work out that I have got 3 moles of water, or 3 moles, sorry, in this 54 grams of water. Now we're asked a second question. How many moles are there in 0.1 grams of calcium carbonate? Now remember, the number of moles is always the mass divided by the AR or the MR. Now this time it's a compound, so it's the MR of calcium carbonate. So the mass is on the top line, and need to work out the mass of 1 mole. Calcium carbonate has got the formula CaCO3, we've met it before. So if I go then and I work out its MR, calcium's top number is 40, carbon's top number is 12, Oxygen's top number is 16, but there's 3 of them, so 48. When I add that all together, then I find that that adds up to 100. So the mass of 1 mole of this calcium carbonate is 100. 0.1 divided by 100 then is 0.001. So in this 0.1 grams of calcium carbonate, we have 0.001 moles. Now if we go on to page 135 and we look at 3 more examples. How many moles are in 1 gram of sulfur? Now remember, the number of moles is the mass divided by the AR or the MR. So therefore it's 1. Remember, the AR of sulfur is the top number, which is 32. I can work out that there are 0.03 moles in 1 gram of sulfur. How many moles in 10 grams of mercury? Well, it's the mass divided by the AR. Mercury's top number, its relative atomic mass, is 201, read from the periodic table. I can work out that there are 0.05 moles. How many moles in 37 grams of calcium hydroxide? Well, it will be the mass. This time it's a compound, so it's the MR. I've got to work out the MR of calcium hydroxide. So 1 calcium is 40. 2 oxygens, because it's in the brackets, is 32. 2 hydrogens is 2. When I add that all together then, it adds to 74. So therefore the mass is 37. The MR is 74. When I plug that into the calculator then, we have 0.5 moles of calcium hydroxide. So when we're asked to work out the number of moles, it'll always work the same way. We'll take the mass that we're told in the question, and we will divide that by the relative atomic mass if it's an element in the question, or the relative formula mass if it's a compound in the question. Now folks, just before I leave you to practice some, I would like you to take a look at number 9, and we're still on page 135. Now this time we're asked, what is the mass? And remember, we rearranged the formula and we writ the other 2 possibilities up at the top of the page. Now if we're asked for the mass will be the number of moles times the AR if it's an element, or the MR if it's a compound. So in number 9, I am told the number of moles is 4. We're talking about sodium chloride. So sodium chloride is a compound. I've got to work out its MR. So sodium's top number and chlorine's top number added together will give 58.5. So it will be the number of moles times the MR, and when I work that out, I find then that the mass of 4 moles of sodium chloride would be 234 grams. And if you think about it, if 1 mole is 58.5 grams, well, the mass of 4 moles will be 4 times that. So it's important that we learn this expression for the number of moles, but it's also important that we're able to rearrange it depending on what the question asks for.